Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam. We shall start with the lesson light energy, what we have seen in the last class. I think we told about Jyotir Dhyana. Have you practiced it? No. I think you are not guided about it. Some Balvika children know it. Anyway, you can try that Jyotir Dhyana, that is seeing light in us and also seeing light in all. So the light is something very, very important in life. So the light is in me, I am in the light, I am the light, said Jesus. So that God, light is nothing but God only. So it's a form of energy which is very, very important for all the beings, not only human beings, plants also, animals also, birds also, every creature in this universe need light. Now let us see something more about light. Before that, we'll just revise what we have studied in the previous lesson, okay? First of all, we started our discussion about light energy. Whole universe is filled with energy and motion, says physics. Physics is defined as that branch of science which deals with the energy and motion. So, for a motion of bodies, energy is needed. And light energy is one of the important forms of energy. Now, what are the uses of light energy? We can see all the objects around us, is it not? And which is a source of energy, light energy? Sun. So without sun, you cannot expect any movements or any transformations in this universe, in this world at least, okay? So, the stars, what is seen in the sky in the night time, there are also different forms of sun only, is it not? So, light is important for the plants also, for the production of food. And because of light only, that energy of light can be converted into heat energy, is it not? And this light only is responsible for all the experiments what you do in the laboratories, and it is a source of all forms of energy. And there are so much beautiful forms of light. For example, the rainbow formation in nature, that's also effect of light. The sunrise, the sky is blue in color, right? But in the morning and evening you find the sun to be red in color. That is again a formation, again a effect of light, which you are going to study later, right? So like that, all the interesting phenomenon what you see in this universe is all the forms of light. And also we have seen the properties of light. First property of light is reflection of light. So what is needed for reflection? We want mirrors. What is a mirror? It is a flat surface, or it is one of the surface is polished. It need not be flat only. If it is flat, we call it as plane mirror. And if it is curved in nature, we call it as spherical mirrors. There are two types of spherical mirrors, convex mirror and concave mirror. So also we have seen the laws of reflection. There are two laws. One is angle of incidence is equal to angle of reflection. Second is the incident ray, the reflected ray, the normal all lie on the same plane. These are the two laws of reflection. Also we have seen about image formation in a plane mirror. There are two types of images. One is called real image, another is called virtual image. So what do you mean real image? Real image is one which can be caught on the screen. And what do you mean virtual image? Virtual image cannot be caught on the screen. And real image usually will be inverted in nature. Virtual image will be erect in nature. And one more thing is, you might have seen in your mirror. Some of you are very interested to see mirror every day, right? What do you do before coming to school or going to any function? You will be dressing your hair. You will be seeing your face, right? Putting powder and all. And then you use a mirror. So one more property of mirror is, if you raise the left hand, it shows the right hand. If you raise the right hand, it shows the left hand. What is that property called? Lateral inversion. Is it not? And one more thing is, the distance between the mirror and yourself or object is the same as the distance between the mirror and the image. Is it not? So these are some of the things which you have already studied in the previous class. And also the property of reflection, which I was just now discussing. So these are some of the interesting factors about reflection of light. You might have heard about, if you go to a pond, you get reflection. Is it not? If the water is very calm, the reflection of your face will be there on the water surface. And that is called as plane surface. But if you just throw one stone on the plain water, what happens? There will be ripples. So your reflection also varies. And that is why it is called diffuse reflection. Is it not? So in diffuse reflection, there will be variation. Okay. So these are the things which you already studied. Now let us see some home assignment. Have you worked out? The first question was differentiate between real image and virtual image. And the answer is real image can be caught on the screen, virtual image, and it is inverted in nature. Inverted means what? Suppose you have an object like this, say a candle burning, its image will be in the opposite direction. That is called as inverted. So this is the object, this is the image. Okay. Real image is formed due to the light rays meeting at the screen. So that means you can get in the screen. That's why it is called as real image. Okay. Coming to virtual image, cannot be caught on the screen. And that can be seen within the mirror only. And it is erect in nature. What erect means what? As is the object, so is the image. It is called as virtual image. And virtual image is formed due to the light rays appearing to meet at the screen. Appearing to meet, not meeting. It looks like that. So these are difference between the real image and virtual image. And second question, when you are standing in front of a plane mirror, a virtual and correct image of you is formed. if someone is taking a photograph of it using camera, what will be the nature of an photograph? So in camera, the image will be real. I think all of you know in a camera there will be, see even now you can see because of camera, there is one camera, facing me now here. So because of beautiful camera, all of us sitting in different places of Karnataka and even abroad, outside, can hear me, can see me, So give thanks to the camera and the cameraman, because the cameraman only all this is possible, right? So here the image will be real, because that convex lens what is there, it takes the image and there will be a screen behind it which will make it real. Okay, and this is one camera. Of course, so many cameras in the market also available, starting from 100 rupees. Toy cameras are there, for 100 rupees also available, up to 1 lakh also it goes. The camera what I am seeing is nearly 1 lakh, because the configuration is such. So this is one of the famous companies called as Sony camera. I am not advertising camera, I am just telling you. And here are some adjustments there. And this is what is called as a convex lens, with which this is formed, and there will be a screen behind it. And this is how you see, different, in TV. In TV also you can see all the images are formed, right? So this is just for your, interest purpose. We are showing this because how the photography is taken. Now you can take in mobile also. Nobody will go for a photo studio now. Everything is available in mobile. You can take any photos in mobile, right? That is what you have seen as a homework. And third question is, image of object placed 10 centimeter from the mirror is formed at 10 centimeter behind the mirror. If the object is displaced by 4 centimeters towards the mirror, what distance will be the image displaced with respect to the mirror, with respect to the object? So there is an object at a distance of 4 centimeter. You must tell where will be the image formed, that you must tell. So answer is, from the mirror, with respect to the mirror, object will be displaced by 4 centimeters. That means suppose this is a mirror and this is the object. Now if the distance is say 4 centimeters here, and you can see this behind 4 centimeters, that is the meaning. When you say about mirror, coming to the object, the distance of the image from the object will be 8. So this is 4, behind 4. So 4 plus 4, 8. In between you have mirror. That's what is called as the one of the properties of the mirror, especially plane mirror, right? And now coming to today's topic, different kinds of lights are there. And one which you see in our eyes, that is called as 400 to 700 nm. And that is called as visible light. And can you tell me what are the different colors in the visible light? Of course, you are going to study in the last topic of this lesson. And the colors are what are called as Vibgayar. So Vibgayar means V stand for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. This is called Vibgayar. So every white light is made up of these 7 colors. And the series of these colors we call it as spectrum. And where do you see it? We can see in the prism, the 7 colors, the band of 7 colors. And where do you see it in nature? That you see in the rainbow. When you will see rainbow? In the rainy season, either in the morning or in the evening. If it is in the morning, you can see the rainbow in the west direction. If it is in the evening, you can see in the eastern direction, opposite to that of sun. So this is something about visible light. Also you have infrared light. So red will be the least bending ray. The light of wavelength more than that of red is called as infrared. So after that red you have what is called as infrared light. And third one is ultraviolet rays. The light of wavelength less than 400 nm, that is violet color, is called as ultraviolet rays. Now you may ask, where do you get all these lights? Is it available in shops? No. It's not available in shops. It is everywhere it is available. How? In the form of sunlight. In sunlight, we find all these kinds of light. Visible light, infrared, visible light about 50%, infrared about 40%, ultraviolet is about 10%. So that is continuously coming. That is why almost many people you might have seen a morning walk and evening walk. In morning and evening you will have ultraviolet, and that will be good for health for some extent, not much. So these are the 3 forms of light you find in the sunlight, and they are good for, they are essential for all the living beings. Now something about sun now. What is sun? Sun is the dearest and nearest form of energy. And you must be grateful to sun. Is it not? That's why all yogis or all those who are interested in yoga, they do Surya Namaskara. That is offering salutations for the Lord Sun for giving so much for us. So even our eyes are compared to sun, and sun is the source of all energies. About 50% of visible light, 40% of infrared, means they are also called as heat. They are coming as heat, and 10% of UV light. And sun radius about 3.92 into 10 to the power of 26 joules of energy every second. Then you may ask, where does this energy come to sun? Sun gets this energy by a reaction called thermonuclear fusion. You might have heard there are nuclear energy. Nuclear energy is energy between the protons and neutrons. It is bombarded by a neutron of suitable velocity, you get that energy. And in sun you have that fusion reaction where hydrogen is converted into helium, and it is being there for millions of years. And due to this process, enormous amount of energy is released. And every second so much, don't think it is a very small number. 10 to the power 26 means what? 26 zeros you must put. So much joules of energy is released from sun. Luckily we are at a sufficient distance from sun. Something like 1,86,000 miles, right? So that's why we are not feeling the hot so much. But in some places, if you go to Bijapur or Gulbarga, you find more temperature there, about 43, 44, 45 it goes. And here in Mudinali it is something like 35. Because we are at a sufficient distance from sun. That's why we don't feel it. and Earth receives about 1.388 joules of energy per unit area. What do you mean per unit area? 1 square centimeter. 1 centimeter length, 1 centimeter breadth. That area is called unit area. And 1.388 joules of energy is Earth is receiving from Sun for every second. Like that, there are so many things, facts and figures are there concerning Sun. And coming to spherical mirrors, there are two types of spherical mirrors. One is called convex mirror, another is called concave mirror. That which is like a, see, this is, if you see the example of an hand like this is called concave. The word cave means there is empty space, and this is called convex. Here is you are shown with a spoon. All of you take a spoon in your house which is new and clean. See your face there, and there are two surfaces for the spoon there, not in the handle, here. And one is called concave surface, another is called convex surface. So a spherical mirror is a section of a hollow sphere. So this is taken from a sphere whose inner or outer surface is polished. One on the surface should be polished. Okay, then only it is called as mirror. And why it is called spherical mirror? Because it is made out of a huge sphere. Okay, there are two types. One is called convex, another is called concave. Okay, convex. Now coming to convex mirror, here there are two surfaces. One is called reflecting surface. It is bulged at the center, and the inner one is called painted surface. Okay, so it is a mirror in which the reflection takes place from the bulging surface, and the inner surface is painted. With what they paint? They paint usually from an oxide of mercury. Mercuric oxide is one of the substances where they use for painting it. Why do they paint? Just to get the reflections. Okay, so this is about convex mirror. Other one is called concave mirror. It is a mirror in which the reflection takes place from the cave side, and here outer surface is painted. This is called reflecting surface. Suppose you have a spoon like this. This is called reflecting surface, concave, and this is called painted surface. If it is convex, this is called painted surface, this is called reflecting surface. Inner you have painted surface. Okay, this is the difference between concave mirror and convex mirror. And now coming to the important terms of spherical mirrors. The midpoint of the spherical mirror is called the pole of the mirror. Okay, that is every mirror will have one midpoint, that is called pole. We are going to see it shortly. And center of curvature, the center of a hollow sphere of which the spherical mirror is a part. So just imagine a big ball, right? Transparent ball. And if you cut one portion of it in one corner, then you get the whole huge sphere is there. No, that is the center of that sphere is called center of curvature, called C. And then you have radius of curvature, the distance between the pole, namely P, and center of curvature, namely C, the distance PC is equal to radius of curvature. It will be equal to PF plus FC. What is F? F is the focal point or focus. So distance between focus and the pole is called PF, and this is FC. So the sum of these two will be PC, and in short terms we call it as F plus F. This is called focal length. The sum of the two focal length will be equal to one radius of curvature, what you call it as R. R is equal to 2F. What is F? F is the focal length. Okay, this is a thing which I already studied, and this is how the mirrors are separated. So this is a hollow sphere. This axis is called principal axis, and the center is called C, and distance between C and this is called as radius of curvature R. Okay, and if the inner surface is hollow here, in case of concave mirror, this is painted surface. In case of convex mirror, this is a radius of curvature. This is called C. This point you may name it, and this is the principal axis. Principal axis, that is a important line which passes through pole and center of curvature. You call it as PC, denoted by the symbol R. It may be small r or capital R. So this is now important terms of spherical mirrors. Principal axis, imagine a line joining the pole to the center of curvature. Principal focus, the rays of light parallel to and close to the principal axis of the mirror on reflection pass through a point. In concave mirror, appear to come from a point, convex mirror, that principal axis. This point is called principal focus, also called as focus, shortly called as focus. That is why the symbol F. Okay, so you should know what is meant by principal axis. It is an imaginary line. On that only all the measurements are made. Okay, this is the fifth definition or term with respect to spherical mirrors. Also, focal length is the distance between the pole and the principal focus of the mirror. That is called PF. Okay, that is denoted by symbol F. Now, this is what happens actually when a ray of light is incident. This is called principal axis. This is the pole. This is the focal point, also called as focus. This is called center of curvature, and this distance is called radius of curvature R, and this distance is called focal length PF, and this is also focal length. So 1 R will be equal to 2F. Okay, so a ray of light coming in parallel passes through C, and another ray passes through F, and here I is called angle of incidence, and this is the normal, and this I will be equal to this I. And we know that angle of reflection is equal to angle of reflection, angle of incidence is equal to angle of reflection, and therefore as these two are equal, PF is equal to FC, and as I is equal to R, these two also will be equal. So that is the meaning, and that is the relation between the radius of curvature and focal length. And let us just derive how it is got. So consider the reflection of light ray IM at M at concave mirror. CM is the normal drawn to the surface which passes through the center of curvature. MF is the reflected ray, passes through the focal point. So angle I is equal to angle R, angle of incidence into angle of reflection. Why? Because it is a law of reflection. So in triangle CMF, MF is equal to CF is equal to, for small aperture of the mirror. What do you mean aperture? The bending, that is called aperture here. Okay, then MF becomes CF. And therefore PC becomes PF plus CF. That is PF plus PF, that is 2F. What is that F here? That is called focal length. So R is equal to 2F is an important relation, where R is called radius of curvature, F is called focal length. I think most of you understood, which the figure I just now shown you. You must have the figure for this, then you will become it clear. And now coming to rules of image formation. One of the rules is a ray diagram for image formation by mirrors can be drawn by taking any two of the following rays. This is called ray diagram, because we cannot show it on the book how the image is formed and all. What you do there? We will draw ray diagrams. So ray diagrams. And how do you do it? You must take a pencil and scale. The point where these two rays meet will in the image point, which determines the position of the image. So what two rays? So the two rays are one ray. So let us see what are the two rays. So first these are the rays you have to consider. One is ray striking the pole. The ray of light striking the pole of the mirror at an angle is called reflected back at the same angle on the other side of the principal axis. That is ray number 1. That we will see now. Concave mirror, the ray parallel to the principal axis is reflected in such a way that after reflection it passes through the principal focus. What is it called? Principal focus? F. So when ray in case of concave mirror, it passes through F. But in case of convex mirror, it appears to come from F. So this is the first ray that passes through pole, and that passes and in an angle reflected back at the same angle, right? Now let us see the figure of it. So this is the concave mirror and this is the convex mirror. Here you see, what is C? Center of curvature. What is F? Focus or principal focus. What is P? P is called the pole. So here ray number 1. This is the ray number 1. It passes through P and gets reflected. Here this is the angle of incidence will be equal to angle of reflection. Both will be same. This is R. And second ray, which is coming to parallel to this principal axis, after reflection passes through F. What is F? Principal focus. And the third ray passes through C. This is the third ray, which reflected by back to the same position like this. So it is incident on this line, get reflected on the same line. The point of intersection of these two will be the place where the image is formed. One of these rays, any two of these rays you can take. And what about convex mirror? In case of convex mirror, they appear to come from F. That is why they show dotted lines. And how do you see it? You must see it inside the mirror only. You cannot see it outside. This can be seen from outside. You cannot see. Therefore, it appears to come from F. And this third ray appears to pass through C. What is C? Center of curvature. What is F? Focus, principal focus. And what is P? P is the pole. Okay. One ray which is incident on the pole gets refracted with the same angle. Second ray which is coming parallel to the principal axis appears to come from F and get reflected with a proper angle. Third ray which passes through appears to come from C, get reflected in the same line. Alright. So this is the rule of drawing the formation of images in case of spherical mirrors. And let us try to a third ray through the center of curvature, that is C. A ray passing through the center of curvature hits the mirror along the direction of the normal to the mirror at the point and retraces its path, means comes back in the same line after reflection. Okay, that is the third. And ray through the focus, one more ray which passes through F, a ray of light heading towards the focus or incident on the mirror after passing through the focus returns parallel to the principal axis. So these are the four, rule of convention for drawing, ray diagrams in the case of spherical mirrors. Now let us try to draw it in different situations. First situation, if the object is at infinity. What do you mean infinity? For example, sun is there. Sun is at a large distance, right? So the rays of light from the sun come parallel to the principal axis. These are the parallel lines. After reflection, passes through F. So this is the second ray. This is the third ray. This is the fourth ray. All of them will pass through F, called as focal point or principal focus. So in case of a object at infinity, you have real image. Means you can get in the screen. Inverted and then highly diminished image at focus. It is actually almost a point there. Object may be big, but you can get a small image, means pointed image you get. That is the nature. So in the exam, what they ask is, draw a ray diagram for the following cases. Write the position, size and nature of the image. This is the position, size and image, nature of the image. Okay. Coming to second case. In this case, the object, we call it as say AB, or if you call it as, okay, I'll call it as AB only here. This AB is called the object. Where it is beyond C. If the object is kept beyond C, what happens? One ray of light parallel pass through F. Second ray passes through C. Two rays enough for us. Third is understood, okay? And this it all happens in the basis of principal axis. So the point of intersection of these two rays will give the image. This is the image. This is A dash, B dash you can call. The A dash, B dash is the image. How is the image? Image is real because it can catch in the screen. It is inverted. What do we inverted? Suppose this is the object, the point is here, na? Inverted means what? It becomes like this. Suppose a candle is burning, let us image. Candle is burning, right? This is the object. And we see it as candle burning upside down. Is it not interesting? Yeah, you can try, okay? You also try. So, it is a real image, inverted, diminished. What do you mean diminished? Means smaller in size. Suppose this is 2 centimeters, this becomes only 1 centimeter. If this is 1 centimeter, this will be half centimeter. That is the meaning of the word. And where does it form? It is formed between C and F. What is C and F? F is the principal focus. C is the center of curvature. Third case. Suppose you keep the object in C only. For example, A1B is the object. As usual, one ray parallel to the principal axis passes through F. Another ray passes through C. So, point of intersection of these two will be here. This is the image formation. And what do you find? The image is real, means can get the screen. Means what? Suppose this is 2 centimeters here. Image also will be 2 centimeters. That's the meaning. Same size. Inverted and of the same size. Where it will be seen only at C. What is C? C is nothing but center of curvature. Objects at C means image also will be at C. Okay. So now a doubt will arise, how to draw this? For that, first thing is you must take a long scale. Draw a line of 10 centimeters. Okay. At one point you name it as say A, or you can call it as P also, anyone. So one point. And draw a mirror like this at this end point. Okay. Then this F should be marked, say about 3 centimeters from here. And if F is marked 3 centimeters, this also should be 3, totally 6 centimeters. Okay. Use pencil and scale only, don't use pens. Okay. That is how the marking is made. That is how the images are got. You can do it practically also. For that, what you want? You must have a concave mirror to start with. Keep a candle. First you keep it in long distance. You find a only small dot is formed. Then you bring it near. Then it becomes a small image. Then you keep it at C. How do you know C? In every mirror they write focal length F is equal to say 15 centimeters. Like that they write. So C is, suppose focal length is 15. This is 15. 15 plus 15 becomes 30. That's how you got C. Okay, these are the 3 cases of formation of image in case of a concave mirror. Coming to 4th case. Here object is between F and C. If the object is between F and C, you find this image in a long distance, bigger in size. It is formed beyond C. So this is the object. One ray parallel passes through F. Another ray passes through C. These two intersect here. This is where the image is formed. Okay. So this is the real image, inverted image, enlarged image, and it is formed beyond C. Suppose you keep the object at F only. It is focal length, principal focal point. Then what happens? you cannot get the image. Why? One ray parallel to principal axis passes through F, another one passes through C. So these two rays will be parallel to each other, and therefore the image is real, image is inverted because it is concave, and highly enlarged image at infinity. What is infinity? We don't know distance. At a long distance it is formed. That is the meaning. So this is the nature of the image in case of the body kept at F. Last case, in case of concave mirror, suppose the object is between P and F. This is the object. Okay, then one ray passes through C, another ray passes through F. So these two appear to come from behind the mirror. That is why it is called as virtual image. See, as is the object, so is the image. Same, it looks the same. Suppose a candle is burning here, this is a light of it, this also is that. So that is what you can see. Here the image is virtual, erect, enlarged, and it cannot be caught on the screen. It can be seen behind a mirror. Now how can we see it? We can see it by seeing at the mirror only, within the mirror. It appears to come from the mirror. So these are the different cases of formation of reflection in case of concave mirror. In case of convex mirror, you have only one case. Wherever you keep the object, one ray will be parallel and get reflected, appears to come from F. Another ray will be passing through C. Again, that C is imaginary. And then the point of intersection of these two rays, that is the image formation. It will be always small. Suppose this object is 2 centimeters, it will be only 1 centimeter or even less. So it will be always formed like this only. That is an example of convex mirror, and the image is virtual, image is erect, image cannot be caught on the screen. Okay, this is the only one case in case of a convex mirror. Now we will put it in a table form now. The position, this is the position, nature and size of the image can be summarized. Okay, so for case of concave mirror, you have between P and F, whatever you have seen just now, the position of image is behind the mirror and it is virtual, larger in size. If the object is at F, the image is infinity, you cannot get in the screen. Real, highly enlarged. Between F and 2F, image is formed beyond 2F. It is real, larger in size. These are the three cases. Coming to other three cases, at 2F means C. Image also at C. Nature is real, same size. And beyond 2F, the image is formed between F and 2F. It is real, smaller in size. At infinity means coming at a long distance like sun. The image is formed at F. Real, highly diminished, means a point like. For convex mirror, we have anywhere if you keep the object, the image will be formed between P and F. It is virtual, always smaller. This is the table form. What we have done in the previous case, we are seeing in the table form. Now let us see some uses. Anything and everything you study, you should know why you are doing it. For example, all of you know why you are playing. That's why you enjoy games. How many of you enjoy games? Raise your hands. Okay, all will enjoy games. Why? You get enjoyment. You forget yourself. You will be fresh. You know the purpose. And some of you are very interested in eating. How many enjoy eating? especially those who are fat, with the belly stomach. They enjoy eating with more number of items, especially festival times. They enjoy because they know why you are eating. It gives energy, it makes me strong, it makes me taller, it makes me fat and all. For everything. Now we are coming to school, for higher studies, for our living better, all the studies are necessary. So some enjoy studies also. Some enjoy prayers, early morning, evening and all. Because they get peace of mind, they will be one with God, nearer to God and all. Are you doing prayers daily? Please do it, okay? Morning and evening, every day you have to do prayers. So what I mean to say is, you should know purpose. Here also, why the plane mirror? What are the uses? In looking glasses and in construction of kaleidoscope, telescope, periscope, etc. Scope means vision. About that we will show a little later how it is. Telescope is is device in which a large distance can be seen in the shortest distance. Okay, there it is. Plane mirror is used. Periscope also you can construct yourself. And then for seeing around the corners, this plane mirror is used. As deflector of light also, plane mirror is used. And coming to concave mirror, it is a reflector in searchlight. Concave searchlight they use it. Headlight of motor cars and projectors. Motor cars you have seen? The headlight will be having a concave surface. There will be a bulb inside and it covers large distances. Floodlights to obtain a divergent beam of light to illumine buildings. Suppose some building construction is going on. Then to illuminate they will use the floodlight. And in reflecting telescopes etc. So these are some of the uses of concave mirrors. After knowing about plane mirror and concave mirror, now we are coming to convex mirror. So in convex, see, you might have seen in motor cars. So this is what is called as rear view mirror. The right side of the driver. How many know driving? Yeah, some may be knowing driving, especially four-wheelers and two-wheelers also. Don't drive without license. Okay, it is government rules. At least it should be major, 16 years. Below 16 years, you are not supposed to go in a vehicle. Okay, in vehicle you see in the right side one mirror is there. That is called as rear view mirror. What does it do? See here, this is a rear view mirror. We show the image of the vehicle coming from behind. Small image, not bigger image. Okay, that is the advantage of convex mirror. So small image of the buses, cars or vehicle coming from behind can be seen this. That's why it is called as rear view mirror. Motor cars, buses and scooters. So this is an example of a bus, double decker what you call. And nowadays KSRTC has introduced the double decker buses. And in many states it is there already. And as safety viewers at the dangerous corners and on deck of the double decker buses. So this is used as a safety mirror. So convex mirror is very, very important as far as the vehicle is concerned. And we have studied the property of the images. That is very helpful. Now coming to home assignment. First question. In what condition the image formed by concave mirror is virtual? Second question. Find the position of the object placed in front of a concave mirror of focal length 20 centimeters. The f is 20. And image is formed at a distance of 30 centimeters from the mirror. So you must tell position of the image. Okay. Write the nature of the image formed in a convex mirror. And last question is, convex mirror is used as a rear view mirror in vehicles. Why? Okay, come prepared for the next class. Thank you.